Hello everyone and welcome to this first video of the SCADA and Industrial Controllers course. My name is Panche
and I am Daniel Fernando Díaz.
And we are going to present to you the work done in this first module of PLCs and Digital Twin.
A notable advantage of the digital twin model is the testing of stops that require an automatic return to the home position of the machines, commonly called reset or safe stop. Since the communication between the PLC and the programming software is carried out by TCP connection, it can be listened to be a new element, the digital twin. The digital factory and the physical machinery can send and receive control commands to the IP address of the PLC. This allows the interaction between a physical PLC and a virtual plant. This data management can be extended to a SCADA supervision system.
With the RS-Links Classic, we can choose between the different types of communications drivers available, like Ethernet devices or virtual backplanes, to start to work with the PLCs. The communication between the field level and the control level in the automation pyramid is done by industrial communications like a wired connection. Now, we can use an Ethernet cable to connect our PC with the local network previously configured, or even connect to the VPN from the comfort of our home. Once we have established communication with our local network, we can open the Studio 5000 Logic Designer, select our PLC, download the program to CPU and go online to see the logic running in real time. Now, how does this program work? This main routine is composed of different runs in this ladder logic. First of all, we need a latch to keep the belt conveyors active when we push and release the start button. It is important to add the inputs and outputs for our digital twin, so we can see the sequence in the buffer station scene of factory I/O. When the sensor in the buffer conveyor exit detects a box with the falling edge detection, we are going to wait a half second with a timer on delay instruction before we activate the stop blade to block the boxes from continuing on the conveyor line. If this first sensor detects another box, but this time in raising edge detection, we will stop the buffer conveyor temporarily in order to prevent the boxes from colliding with the blade. To the end of the exit conveyor belt, we can find a second sensor that when detecting the box, it will open as a switch to release the blade and activate the buffer conveyor again, allowing the next box to pass and then repeating the process indefinitely. In addition, we add a counter in this second sensor to display how many boxes have left the station in the panel of factory I/O, and a reset button to restart the counter back to 0. After the successful simulation of the program in the digital twin, it is time for action. For this implementation of the buffer station with the physical actuators available in the automation lab, We use a three-phase electric motor to represent the buffer conveyor that feeds the production line. A single acting pneumatic cylinder for the exit conveyor that will be activated during all this process. And finally, a double acting cylinder for the blade in order to block the boxes in the buffer conveyor. In this challenge, we can see how the use of the digital twin technology from the Industry 4.0 can be used to simulate and validate the ladder logic in a PLC without the need for a physical assembly in the field level.
As a result, we observe that the digital twin can serve as supervision in assembly and commissioning of control panels and physical machines, since it can operate the PLC without requiring connections to sensors or actuators. Also, the possibility of using the network protocol to use alternatives to the factory I/O program, such as those offered by companies such as Siemens, Autodesk, Dassault, among others.
Thank you for watching.